Good afternoon, everyone. Thanks for joining our workshop today in track 4. So far, we've had a very interesting first day at the FTTH conference with a lot of insightful information learned through different workshops. I hope you guys had the chance to also visit some booths and do a little bit of networking on the platform. It's been most interesting for sure. Today, there's no surprise. I guess our workshop also is around the FTTH, of course, but we're looking at it from a comparative angle. So we all know that FTTH deployment has its share of challenges, and these challenges can certainly differ depending on the context you're in. I think we can learn a lot from comparing these contexts, and this is what we're going to talk about today. So 2 different operators in 2 different countries, and also an engineering firm working within those processes, and see what their experiences has taught them. And of course, by the same token, we will touch on incorporating in those processes planning and design automation software and see how that impacted their end-to-end. And we'll start by setting the scene, give some brief intro of each company so that you guys know what their environment is like and their context within the FTTH deployment. And then we'll move to, hopefully will be, I think, a very interesting panel discussion, exchanging ideas, maybe asking ourselves some challenging questions, and everyone here can share some good information and best practices. So first things first, allow me to introduce our distinguished panel. So first of all, I'd like to introduce Pablo Rosso, Chief Operating Officer from Yungo, an engineering firm based out of the Czech Republic. Pablo, thanks for joining us today.
Thank you.
We have Peter Wissenberg, Head of Fibre Networks at Proximus. Proximus, of course, for those who don't know, is Belgium's incumbent operator involved in national FTTH rollouts. So Peter, also thanks for joining us.
Hello, good afternoon.
We're also joined by John Franklin, CTIO of CityFibre. So CityFibre is UK's largest alternative operator, also deploying massively, I think is a good word, around the country. John, so thanks for taking the time with us as well.
Thanks, Kelly. Thanks for the invite.
And finally, for myself, I'm Kelly Fournier, Head of Marketing and Sales at Comsof. So Comsof, also based in Belgium. I would say that we're probably the 4th best thing to come out of Belgium after beer, chocolates, and apparently Jean-Claude Van Damme, it seems. So we'll see where that goes, that debate. Again, just looking at the discussion today. So comparing these 2 operators in Belgium and UK and see what their role is with planning, design, automation, for example, but we'll also touch on different subjects. If you don't mind, I will go first for the company introduction. So we'll talk a little bit about Comsof briefly, and then move on to you guys and get your stories as well. So for those of you that has attended the workshop 1A this morning about digitization, you've probably seen my colleague Jonas introduce Comsof, so bear with me. I'll try to complement his slides with my own and give you further information. So briefly, Comsof has been around for 23 years, although our main focus is on software development for network planning and design of telecom networks. We have around 50 employees, a little more than 50 across 2 offices, namely our head office in Belgium, Ghent, to be more precise, where I'm based out of, as well as Toronto, Canada. Although our R&D auto design was founded in 2004, the company was actually founded in 1998. So we've been around for quite some time. We've been involved in over 200 projects in more than 50 countries, which has given Comsof really high-level experience in FTTH planning and design. We are a software company, really focused. Our core competence is in the software development, really in the development, but also in the delivery of the software for our clients and supporting our clients throughout the use the software to make sure they're successful in their FTTH planning and design. But as well, we do have some certified design partners who are well trained on using Comsof and able to provide some design services. You will see Yungo being one of those partners. If we move on, in a nutshell, you can look at our software basically as a powerful calculation engine, which gives you the power to make optimized designs that can later be built in the field. But like any engine, it needs some sort of fuel to operate. For us, this fuel is essentially what we refer to as input data. So this is GIS-based information that allows the engine to operate optimally, right, and calculate the most efficient and optimized design. I'm pretty sure we will have questions and comments around this data today with the rest of the panel. For sure, this is going to be part of the discussion. But as well in Comsof, you can also configure your rules, network topologies, as well as your materials and your cost so that it fully fits your context and the output is based on the prices that you have within your environment. You can even use the software to compare different network topologies and architectures to see how that impacts as well the output, your bill of material, and your overall cost. And speaking of bill of material, that is a very data-rich output that is provided by the software. So in terms of the value of automation for a project, if you look at a high-level process, you'll have your plan, design, build, and operate. You could seem to think that planning and design automation software simply speeds up your planning and design activities, but it does a lot more than that. Its power can really be leveraged throughout the process, from planning a cabinet area to an exchange-wide area and going all the way to a nationwide calculation to have a stronger business case. So it's a wide range that it impacts, and you can run in the design stage multiple iterations to make sure that your designs are optimized, look at different scenarios, take different routes, and see how that impacts the output, the budgets, and your bill of materials. We know quality designs equals quality builds. If you optimize your designs, of course, efficiently, you will get some gains in your process, but not only in your process, but in the overall cost to build your network. And finally, the very strong point is the potential integration with physical network inventory platform, which was also discussed in length in the workshop this morning, and which is a very important part of the ecosystem that needs to be considered. Now, one thing that I come across a lot in the industry, having been doing this for almost 20 years now, is although telecom is pushed through technology, it's still a relatively old technology-based industry, right? With copper networks and networks that have been built for over 100 years. I come across the classic, we've been doing it this way for years, reasoning quite a lot. And this is still a big barrier. And design automation is somehow, in the scale of things, quite new, but still represents, I feel, a disruptive change in the industry in the past years, breaking down these barriers and trying to move away from the traditional approach. But when it's all said and done, we clearly see how automation really changes the way we do engineering of our fiber networks. Essentially, our clients, two of which are here today, so I will let them speak about this more than I can, but essentially there's 4 pillars here that is usually communicated extensively to us. One is, of course, the speeding up of the process from 50 to 90% savings in time, cost effectiveness in the build. So depending on the use case, there is some savings in the build. Even a 5 to 10% cost saving in construction, I think we can all agree are substantial savings. So it's not just looking at the design costs themselves, but the actual build costs. Uniformity, quality, of course, always a big subject. And then finally, one important thing in my experience that I've had that pain in different deployments is the variable cost between your estimated planned costs and then your actual as-built costs, and reducing those variations is a very important part of the journey. Key components of automated design. Well, three things here. One, I already mentioned the input data, so GIS based information, which is very important. Street center lines, buildings, dwelling unit counts, things like this, as well as your existing infrastructure. So Proximus's existing infrastructure, for example, or in the UK, we talk about things like PIA or things like this. And then you have the setup of your network architecture, your configuration of the rules, and how you want to build your network. And then, of course, the list of your cost information materials as well as labor. And the feature of the automation solution is this, like I mentioned, strong calculation engine, gives the designer full power to bring edits to the designs to make sure that they are constructible in the field. And this is all based on a very powerful, scalable algorithm. Eventually, the output of the software, you get a network design, an optimized network design with specific detailed reports and a potential to integrate into your ecosystem. In a nutshell, our key markets are, well, almost self-explanatory, but yeah, network operators. So whether they're incumbents, tier 1, tier 2s, etc. These are the main users of our software, as well as their engineering design firms that leverage the power of the software for their customers. And then eventually we do move towards municipalities, governments, ministries, even consultancy firms, and believe it or not, material manufacturers can also benefit from the use of the software. We also pride ourselves in integrations. We do believe that working as a team is much better than working in a siloed approach. The one-stop shop solution or the jack of all trades is a tricky approach. So we don't claim to do that. We know what we're good at, and that's what we stick to. So we do integrate and collaborate with different partners, whether it's from a GIS integration perspective or other technologies like wireless or softwares that, such as ERP, work order management, so on and so forth. And I've already mentioned about the certified design service partners, such as our friends at Yungo. We'll have a chance also to.
Thank you, Kelly.
So this is my portion. I would like to give it to Pablo. So this is your turn.
Yeah, thank you very much for the introduction before. My name is Pablo Rosso. I've been in the telco business for the last 12 years, from which in the last 5, I've been working for Yungo. I will be very brief, talk about what we do. We are an engineering company. We are based in Czech Republic. As I mentioned before, we have been in the market for the last 5 years, cooperating with customers in more than 10 countries. Today, we are reaching the million design engineer connections. Hopefully by the end of the year. It's for us is quite an achievement being such a small company. We, as I mentioned before, we work, or as it says here, we are tool independent. However, we've been working with a partnership with Comsof since we started. As any other engineering company that are cooperating with other operators, like in this case CityFibre or Proximus, we offer the flexibility that today is needed for them for achieving the high levels of deployment that they want to do in the coming years, and they will speak and they will explain later. So the flexibility and the scalability is something that we are very good at it. In the last 5 years, we grow from 5 engineers to 70, so we duplicate our size every year. That is thanks to our approach to automations and to the use of different tools that are in the market. So thanks to that, we were able to grow, and we continue growing. We have our own plans to grow together with the same way that the operators here. with the deployment. And one specific thing about ourselves and an added value is, as I mentioned before, since we started, we start collaborating with different customers all around Europe, and that is giving us the know-how of the learned of the good and the not good experience from different operators, construction companies, and so on. And what we create internally is a synergy between the different teams that are operating together, and we try to give back this knowledge to our customers. So we prepare workshops, we help them with the automations to prepare the data or the input data for using tools as Comsof to produce detailed design. And later on, we also produce some workshops and some consultancy services to show them what is being done at the other side. So we want to, that's why we are here, to collaborate and to cooperate with them and try, being a small company, try to make as much impact to improve the deployment and the quality of the services around. So if we move to our, it's quite slow, sometimes it gets stuck. So Paul, can you move to, yeah, thank you. So if you move to our services today, and what is based on the engineering service for FTTH, which is one of our main focus, we like to present it as a V model. Whereas everything that happens before the construction is described here with the market analysis, master plan, high-level detail design, for which we use all the input data that you were mentioning before, Kelly, and we use tools as Comsof to implement these designs. Usually, the other service that we provide is during the construction. There are always things that you cannot discover when you do the service of the areas, and you find out existing infrastructure you cannot use. So you need a company that can fast modify your designs to change the topology to adapt to the needs fast, and that's what we do. And last is what you mentioned after is as-built processes, collecting of the information for producing the inventory systems. So also that a part of the revisions, the maintenance support of the inventory system, and as well migrations when you have acquisition of different companies and you need to clean data and you need to create a consistent inventory, or what we call the digital twin. So through all this experience of these 5 years plus the 70 years of our founders in the field of construction, we start using the consultancy and all these lesson learned to find other services that we could provide, and what are the needs and what are the flaws. You mentioned before something very interesting, which is the prediction on the cost. And for example, if I move to our next slide, if we talk about innovation, we create a few months ago already a department to really reinvest everything that we have today on new services that we can provide in the deployment of FTTH and in other businesses. I'm just going to go through one example so we can move further later to what to Peter and John. So one example of this is, you mentioned as-built. I mentioned here smart build or smart as-built. What we try to do and what we found is that we focus in the deployment, but later on all the stages of transforming this information again in something digital, creating a digital twin that you can manage for you to manage your network, it's usually a pain. And calculating or predicting these costs, or how much it will cost for you to produce this, usually, at least on our experience, is quite not solved yet. So we found out that the key problem here is to try to do all the collecting of this information in later stages after the construction. So we said, why not to try to do it as closer to the construction itself? So why not to use new technologies available? Like in this case, there is a scan trench with leader technology of a camera on top of an excavator, and this is just a point cloud of it. Why we don't use these technologies combined with tools like Comsof that produce the design to do automatic production of most of the information for the as-built? That will reduce manual work and will allow us to spot the difference between what was designed and what was built right at the moment that it's been done. So that can really help to reduce the cost. So that is just one example. I hope that questions come after about this. But let's move on about our relationship with Proximus and CityFibre and Comsof. So today we are working with a team of engineers together with the engineers of Proximus, helping them to clean data and to prepare everything, and later on to calculate the high-level designs. I think that Peter later will explain further all the operations and also the ambitions to grow here. So we are working together with a team of, I believe, around 6 engineers from our side, together with the engineers of Proximus on producing these high levels, and then going back and forth with the construction partners to acquire and apply the site survey information. In the case of CityFibre, we work through their partners. So our input data in this case are the high levels done internally. And what we do, we collaborate with the partners producing the low level designs for them, which later on are checked by CityFibre. They do also the walkouts, and then we do the amendment to produce the final low level design. So this was a short presentation of Yungo and also our relationship with both of our speakers here. So I give the word back to you, Kelly. So thank you very much.
Thank you, Pablo. Really insightful. Nice to see your flow, the workflow on how you work in both environments. We can see it's already different. Hopefully, we can touch on that a little later. But now, without further ado, let's go talk to our operators, and let's start with, well, I have to start with the operator that provides me broadband services in Belgium. So I will hand it over to Peter.
Yeah, thank you, Kelly. Hello, everybody. Just a very brief introduction on Proximus anyway. It's already been said, we are the incumbent operator in Belgium. So we really operate still for 90% of the country today, the traditional copper-based VDSL network. We are offering internet, voice, data, television, IP television services. So no surprises about that, both to residential and the corporate market, of course. When we zoom in a bit on our strategy, so we have a 4-pillar strategy, and the first big pillar, of course, is to deploy what we call the gigabit network, aiming to bring to every household, to every company, the gigabit, be it through fiber or through mobile, and of course supported by a performant transmission backbone. So that is really the heart of the strategy of our company today, and we and our team are of course proud to be part of it and to be collaborating on that. Next to that, of course, we have other axes like the digital native company which we want to become. So we are really pushing forward not only to make our customers become digital and green, but also to become digital native in our own operations and interactions with customers and suppliers. And that is clearly one important point that we tackle today with this concept of using the Comsof software in our designs. All in the end, of course, aiming at growth in our profitability. It's economics after all. But so in the gigabit network, it's mentioned here explicitly also, and that is a difficulty, a challenge that we have, is that we really want to make this network as open as possible to other partners. That is also on the level of the service platforms where we integrate with external service providers, but also on the network itself, where we really want to build our fiber network in an open way so that other operators, virtual operators, also become customer of our network. And this has some influence on the architecture, making it all a bit more complex, what we want to deploy. And therefore, we obviously use the Comsof algorithm to prepare with all the data input, like it was explained before, the most optimal solution design on level of cost and coverage that we can obtain. Concretely, when we zoom into that gigabit network ambition, I have here some view on the volumes. So where we are today is a bit more than 10% of the Belgian households are now covered with fiber. So we started, in comparison to many other operators, quite late with the massive fiber deployment. Mainly because we had a very, very good and a very performant VDSL network with a huge coverage in Belgium, very stable, performant enough for the services which we have been providing to customers up to now. But towards the future, with increasing bandwidth demands, increasing video quality, increasing services with low latency, obviously, we've made the decision to start deployment of fiber around 5 years ago. And there we started discovering how to do it, optimizing our architecture to reduce costs mainly. And there's very intensive use of the Comsof software in those past years. And now, since 2019, we're really doubling our deployment volumes year after year. So from 19 to 20, we did ×2. From 20 to 21, we will do ×2. And which means that we are going to evolve towards next year and the year after into a few years where we want to deploy per year 10% of the Belgian footprint. So going from 10 to 20 to 30 up to 70. So we have currently a plan to cover 70% of the Belgian households and businesses by 28. You see two different colors here. Perhaps, Pablo, do you have a question?
Yeah, if you can give us more details on the volumes in the year by year, and also the differences between the joint venture and the Proximus footprints.
Okay, so indeed, if you look at the overall 6 million homes footprint in Belgium, so we have a plan to cover 70%, which is 4.2 million. 2.2 million is what we are doing and are planning in the white color. So that is what we call our standalone footprint. So that is Proximus entirely on its own, both on level of project management together with our construction partners as on investment. So it's really a standalone investment plan. And in order to go faster, we have founded this year 2 joint ventures, one for the northern part of the country, another one for the southern part, to come with a complementary investment means and dedicated approach as well for the smaller cities up to suburban, where we see some other challenges coming. I already had a workshop this morning where I went more deep into the architectural differences between the standalone and the joint venture, so I will not try not to repeat that here. But so it's really 2 approaches, 2 ways to invest, the one on our own, the one together with the external partners, to deploy effectively this massive volume, because doing 10% of an entire country within 1 year, it is an operational challenge. But we are today confident we are good on our way to achieve that, and that is also the official forecast that our executives are broadcasting to the investor community. So when I zoom now into how do we use the Comsof software, how do we interact with the Yungo team, that is, we will zoom into the part of our standalone footprint. And so on the white volumes where we see this huge increase over the last year, going towards a peak for the next 2 to 3 years. of course, this slide is just saying, yeah, we do use the Comsof software. The fact that Comsof is a Belgian company is easy to do business with, of course, for us, but it's of course not the main reason that we chose to work with Comsof. It's because we were really convinced about not only the algorithms and the software, but also the capabilities to evolve that algorithm, because that's really what we did over the past few years. We continuously invent other ways or other design rules to reduce our cost, which is in our standalone footprint, mainly focusing on the dense city centers. And there we absolutely want to avoid to make trenches, to deploy underground ducts, because that is slowing us down, costing a lot of money. We have the legal right to go on wall mounted, which is not true in every country. But so we continuously optimized based on learnings our requests towards the Comsof algorithm to make the solution that we propose better on level of cost and speed and executability, but at the same time more complex. And that is what has been a great success up to now. We are very happy with that. I'm focusing on what we call brownfield. That is, we have this new overlay network that we create in the dense cities. But in the meantime, we also started developing the algorithm so that we can use it for new construction, new developments, new zonings as well. And we also use it already for a bit longer, in fact, to simulate costs for individual companies asking for a fiber connectivity for which we need to extend our network onto their premises. When we zoom in a little bit again on the brownfield, so it has been told by Pablo before, I think. So we do multiple iterations. We have multiple versions of what we call the high-level design. The first one, of course, being based on all available official data, addresses from national databases, our existing infrastructure, and so on. We do a run, and here we have really realized a setup, server-based setup in close collaboration with our IT teams and the Comsof team to have a very performant environment, because we do that run in principle once a year for the entire Belgian footprint of 6 million homes. So we develop a solution optimizing the deployment with our current rules, and those evolve, as I said, for the entire country. It's a very intensive, huge terabyte data exercise, but it gives us very good input on level of cost estimates to refine on a yearly basis our global rollout plan. To define, we want to go to 70%, okay, which cities are in and which cities or villages are out. So that is one important point. And okay, what we have there on level of business use, it's really good enough to take those decisions. It's not good enough though to do a construction, because the problem in this algorithm, of course, is how intelligent it may be. The input data that we provide is often of a too low quality to really create a design, and that is what we are doing in those iterations 1 to A to B to C that we see further down. And there we see, we started, it was a slide of Kelly where we said, okay, you have GIS info, you have the design rules, you have cost info, and that provides a cost estimate. That is okay, but the GIS info is simply not good enough. So, and we go in different iterations. The first one is going into the streets, validate the official address list, which is in Belgium often very poor quality. So that is a labor-intensive activity. We don't use LiDAR for that. We really go on site, because we not only need publicly visible data, we also need to enter buildings when we have multiple dwelling units to validate exactly how many apartments are in here, because we really want to provide one fiber for every living unit. Once we have decided, okay, here our addresses are completed, then we have a second survey round, which is specifically going to these apartment buildings, because we have to negotiate building by building, how will we do the internal cabling? Depending on the building complexity, building size, we have different solutions. And so after that survey round, that data is captured, and then we do a new run so that every time we do that, we validate more and more the exact solution that we want to implement. And the third one, it's for operators, it's not a surprise. It is because we want to reuse our own infrastructure, and obviously that data quality is not 100% either. So for the important tracks where we reuse existing ducts which are documented as available, for the important ones we also go and validate that, fine-tune that, and then have a final run before we construct. So this run 2C, as we call it, it is almost one-on-one the input for the real design, the drawing in our inventory, which will generate the work orders, will generate the permits, which we ask to local authorities, and then we construct. There is an interesting third one which is being developed, because the reason that we, or one good result of these really detailed level data validations and cost estimates is that towards our construction partners, we can send a project for an entire city or part of a city saying, we are confident that these are the volumes that you're going to do in trenching, in fiber blowing, in splicing, in wall mounting. So this is the price for which you can do it. And so we have a very easy, I would say, purchase order and good receipt process thanks to that. However, at the end, there are always small surprises and deviations. So we are developing a third iteration, which is at the end not designing the optimal solution, but discovering what has been really designed and deployed, and then doing the cost calculation again. So the two-step in the algorithm, design and cost calculation, we do in those first. And then the last one, the design, we replace by a discovery and then do the cost. And then we just negotiate a bit on the highest deviations. So that is really, for us, doing more than just bringing the optimal solution. And that's what we always say, okay, we can do much more with this massive amount of data. If we interpret it, it becomes really information with which we can further optimize our processes and not only just steer our design and construction teams. That is an important point. On this slide, I have already a bit touched it. So we have what we call fiber hoods, which is the neighborhoods which we are going to bring to fiber. We have all the off-the-shelf data. We bring that together with our design rules. And then we have on top, we see the kind of drawings, which are the optimal solutions. And then we have all these Excel-based data coming along with it, which we can process. Looking a bit into challenges, what we are facing today, and I also briefly touched it left and right. First is, of course, on the left, our volumes doubling every year, our manpower or our ambitions to recruit people are not doubling every year. So we need to become more and more efficient. This is also where Yungo came into the picture. So we have these runs. Okay, we don't invest as much as we needed to do before in effective designers, people doing the design, but of course we have people capturing the data, preparing the data in the right formats, uploading, running the algorithm. That is some work, much less than, of course, doing the design manually. But for doing that work, we have requested the support of the Yungo team to do these different initial runs and incremental iterations. So our fiber hoods, neighborhoods typically are around 3,000 living units, 3,000 demand points. And then, of course, we go into optimization. You can imagine, okay, we cover everything, but at a certain moment in time, we invent a rule. The 2-3 most expensive individual units which are really outliers, we would like the tool to suggest what is the individual incremental cost of a living unit. Well, these are all types of incremental complexities that we bring to fine-tune and improve our decision making. So we need more data for that. Our design rules becoming more and more complex. Every opportunity that we get, idea that we get from someone that might reduce the number of underground meters, we put that in new design rules. And so this is becoming a challenge. I think we are almost reaching the maximum complexity that we in the end want to have, because in the end it also needs to be constructed by a splicer and needs to know, okay, which fiber do I connect to which splitter or to which outgoing fiber directly. Then the server environment, I already touched it. So we have regularly a run on our 6 million demand points. That was best a complex exercise that we did, but with a good success. And then, of course, the output, it's not really a challenge, but more an opportunity, what I explained before. We can do much more with this on level of benchmarkings. The way today we select our construction partners, we allow them to give a kind of de-risked price. They give a price set on a meter of trenching, a splice to make, so that is good for them to de-risk. They don't give a price for a city. They give a price per activity. We have prices per material component. And thanks to this, we can, for typical cities, compare in reality the price levels between our construction partners. That is a very positive outcome of this software and the cycle on how we use it. That are the main points I think we should share today.
Well, thank you very much, Peter. Very interesting. One key takeaway that I take from your story is, and it's nice to see that Proximus was able to implement this, is, as most of us know, the further down the process that you find an anomaly, the more costly it becomes to repair. Yeah. And in an FTTH rollout, we know that if you find this anomaly and you're in the build stage, not only will it cost you a lot to do a revision and find another route and so on and so forth and find that solution, but we forget the potential impacts it may have on permitting. So you may have to reissue a new permit request to authorities and municipalities. Absolutely. And in this case, it's nice to see that Proximus, throughout your process, you recycle iterations and then you funnel in more details so that you have more precision on your output. So that's
we invest a lot of time in that. Sometimes it seems as if we take too much time to prepare, but having execution teams in the city center in a standstill, and nothing is worse than that. So we really deliberately invest in that data validation process, and we are absolutely sure that it's beneficial in the end.
Indeed. Absolutely. Well, thank you very much for that. And now, for John, I will leave it up to you to tell your interesting story as well.
Thank you. Actually, just a comment on that, Peter. So same thing around the design side, but I guess that sits under the measure twice, cut once scenario, doesn't it? You're exactly right. So I think we'd be the same. We spend an awful amount of time trying to get our design right, but if that's the case, then you're going to get a better product on the end. So I'm in complete agreement. So thank you for this. Afternoon, everybody. Very quick overview of CityFibre, and I'll get in some similar lines to what Peter's been through already around how we think about design and what some of our challenges have been, just so you can reflect that back into your own design processes. But I guess we should start with, at the highest level for CityFibre, we're creating the third national fibre infrastructure network in the UK. Obviously Virgin and BT or Openreach are much larger networks across the UK currently. So we want to make sure then that we're designing these networks that we're building to meet both today's and the future's requirements of our customers, whether that's business, residential, local government, etc., to enable them to transform their capability and to spark innovation across the footprint that we build within the city. That's at the highest level. That's what we're trying to do. So there we go. So some quick figures. So you can see on the right-hand side where we're looking to build or are building. 8 million premises by the end of 2025. We think about this on a per build area basis. So the more areas we get, the more areas of productivity we get, the more output we get in a consolidated view. So we've got 60 areas that are in mobilization and in build now. And 45 of those are producing ready for service homes as we go forward on a monthly basis. So today, the way to think about our scale is today we're about 65,000 homes coming out every month out of the end of that process. And we need to continue to double that by the end of next year. So as I say, it's the way to think about us. It's a cookie cutter model. That's why our architecture and our design principles are so important to us, because that is build more, put more areas into build or into mobilization, then drive the increasing productivity in each area. You'll get your scaling through the number of homes becoming available ready for service on the back end. So talking a bit more around our design and our architecture, both of which I always believe is very much hand in hand. Can't do one without the other. Kelly said it earlier about how do you want to build your algorithm with your architecture. That's really, really important because the design to me is only applying it to a geographical sense. It's applying that architecture. So we've always had a principle around trying to drive, it's called a well-planned city is the way we've coined it, around being able to take coverage for all fibre verticals across any market, again, now and to evolve as those markets evolve. So some of our architecture might be slightly different than others. We do use some rings, civil capable rings in our design with a view that we can reuse every metre that we've constructed and every pound we've invested to support all of those fibre verticals as they evolve in any city going forward. That's a really key term of ours. So trying to understand where to put the capacity, making the bet around how close you can get to that location that we need to get to in the future with the right amount of capacity for the right type of product is where our architecture sits on. And then before we get into the detailed design flow, the other piece is we've evolved to a full hybrid network build, which is a bit like Peter said, reusing his own infrastructure. We use a lot of BTs or open reaches, sorry, and others as well to go through this. But we've looked at this based on our core goal of making sure we've got control and scale and flexibility going forward for the long term. We've got a mix. So the fibre exchange is our data center. That's our own built, own design, own operated. We build our own core network or feeder network, multi-ducted, high capacity. We have an element of rings at that point in order to get flexibility across our footprint across those build areas. Build areas to us are typically 50 to 100,000 properties. And then distribution network, so that link out into the actual properties, we use a mix of own build, poles, and duct leases from either the incumbent or from others, depending on the asset that's available. And we think that by doing that, it gives us the best way to optimize for our speed, our cost, and our carbon footprint as we roll this out. Because 8 million homes obviously is a large civil engineering task to be done over the coming years. So onto the design pieces, and you'll see some themes coming out exactly the same as Peter talked about before. So you'll see in a slide in a moment, one of our key learnings is we should never think about this purely as a design and as a build, because it has to be homogeneous, it has to be linked, because you can't do one without the other. So we have a high level design, much the same. We design on that rollout plan or that build area, so the 50 to 100,000. We do a very detailed design all the way down to the bill of materials. We optimize the routing through the Comsof platform. We get a draft design pack for us, and we get our first view of our cost per premise passed, and hence the total cost that we can model against to validate at a high level design. It also tells us at that point how much third-party network we're going to be using and how much of our existing network we're going to be using in that footprint. Now, again, just as Peter said, that's data records. That doesn't mean it's accurate at that point. It's the data records that say that's what network is available out there. It goes into low-level design, and we don't use LiDAR either. We have yet to find a way that replaces putting someone on the street to go and do the detailed validation and understand exactly, converting that high-level design to what we call a low-level design down to a build package area, which is a much smaller footprint for us. So we subsets of that high-level design and make sure that we get the buildability addressed at that point. We identify any special engineering difficulties, things that we should be working on earlier before we do mass production, because as we all know, you start a big build and you can't get over a single bridge. You can spend a lot of money and wait a long time for that build. And the job pack, and then an updated cost per premise as well at that point. And finally, I'll go into the build environment, exactly the same thing, but we'll get the as-built back, which will tell us what we've actually built. It will tell us our actual CPP, and it will give us the actual available properties that are available to connect. So the first thing to say there is, as we've gone through this process in the last 3, 4, 5 years, I guess now, it's a two-way continuous improvement loop, and it gives a real challenge with version control around how things change. So in each of these areas, we've seen quite substantial improvements being fed back, whether it's into architecture, whether it's into our rule sets for high-level design, whether it's into design rules or planning rules for the guys out on the streets looking at the low-level design. And also, not a surprise again, when you actually open the streets up for the build, sometimes you need a design change. So all of those have to happen on a recurring basis continuously to make sure we're optimizing our best design going forward, and to make sure that the left hand and right hand are always aligned. And then the last one from me really then is, if you roll all that together, what we've learned over this time is aging designs. So especially when you go to a hybrid environment and you're using third-party networks, those networks change and evolve. So getting too far ahead of yourself on design is a challenge, because when you actually go to implement that design, things have changed. But also you can't go too slow, because otherwise you'll have waiting time on your construction activities, of course. So getting that stakeholder engagement, that means you've got that end-to-end view and everybody understands the inputs and outputs from high-level design coming through to low-level design, to walkout, to construction and as-built, and then on to making sure what's available for sale and for activation is really important. Otherwise we end up out of step, and we have been over the years. So we've spent a lot of time working on that. Evolving architectures, I touched on that before. So that is, every time we go into a new situation or a different type of challenge, the architecture gets updated or the planning rules get updated. How you do that version control through an expanding team. So for us, we're in 60 odd cities now, from the north of Scotland to the south of England, and trying to keep that coordinated and making sure everybody understands the latest updates, the latest engineering bulletins, the latest design changes is a challenge. And that's something that we just got to keep on top of. Data quality, just as Peter said, exactly the same, which is we all rely on the data, but we also all know that the data isn't right. So you've got to build that into the process as you go through. And we've triaged, we've got data sets that have exactly the same data in it, but all three data clashes differently with each other. So you've got to take your best triage out of that data, but always we've yet to find a better way than actually finally getting someone out walking the design in the end prior to build. And then if you sit back to where we are from a scaling point of view, one of the real challenges is we use a lot of design partners and different construction companies, and getting everybody up to scale, up to understanding the detail of the architecture, the detail of the planning rules, the detail of the principles of what we're trying to do is a continual effort. Pre-COVID lockdown, if there's anybody on from any of our design partners, and Comsof definitely, And I say thanks because we had you guys locked in rooms in Milton Keynes for many, many weeks trying to get to this point. But it's paid off quite substantially because that gets that alignment around making sure that we've got that scaling support. We've got different design partners helping each other. We've got Comsof helping everybody, and we're sitting on top, making sure we're all aligned and everybody's getting that same level. And then finally, we spent a lot of time and a lot of investment with CityFibre resources doing QC on high-level design and on low-level design prior to releasing it. But we've now seen that right first time pass rate as people have gone through that scaling support and that education process. We're now in the 90-odd% right first time from a quality point of view before we go to the field. So it's a real investment area. If you're going to go to scale, we've found getting people aligned and getting scaling support into all of your contractor base is really important. Continual feedbacks, as we've talked about before, and then the final one for me is don't overcomplicate it. I think it's very easy to start drilling into every single area, and the next thing you know, you've got 57 different actions heading down that process that become completely confused by the time you get to implementation. One of those is an example for us, limit of construction. It might be a UK term, but it's those would be properties that we can't make ready for service for whatever reason. We need a way leave, they're on a private road, they're problematic, the council can't give us access to the road yet, etc., etc. There are 50 different reasons why you can't do something. We started off trying to track the 50 different reasons so we could understand exactly why we weren't doing things. But when you're doing 65,000 a month and you're trying to scale, you know that the reasons aren't coming back for the real reasons. It's over complex. So we're looking to reduce our number of codes and reasons for that so that we can start to get to the bigger picture and simplify how we drive this through. So finally, as the results, if you get all that right, then for us at least, a coherent end-to-end plan, super important for everybody. For us as a wholesaler, we don't sell direct, so as a wholesaler, this gives us a much better reliable forecast into the ISPs. Super important. They go out and do the marketing. They go out to get the customers to sign up. They sign up through the ISPs, not through us. So making sure they understand who's coming, when we're coming, with what, when and where. And then ever closer alignment between expected and actual CPP, doing that high-level design cut, that low-level design cut, and the actual cut, and making sure that we have, I think on one of the previous slides, I think on one of your Kellys actually, was around the handful of percentage change, and we're seeing that in reality. Again, that's that measure twice, cut once. If you get it right on the front end, then you can get more confidence on the back end. You're going to be able to hit the cost. So with that, I'm going to skip through a couple, and I'm going to hand back to you, Kelly.
Thank you so much, John. Really interesting to hear the comparison between you guys. So one takeaway maybe from me is you can see some differences. So for example, the fact that you guys, John, are very dependent on third-party infrastructure and availability of that infrastructure to start designing and building, whereas this is a little different from Proximus. However, you guys do share one major pain, and this is something that I hear everywhere, regardless of your geographical location around the world, is really around the fact that the data that is available, whether it's your own data or a third party's data, it's really difficult to get accuracy there. And this brings me to another thing that I find also super interesting, is that you both seem to agree that investing in time and effort, regardless if you're using a design automation platform like Comsof, for example, but even if you would be doing traditional manual designs, you guys seem to, and correct me if I'm misinterpreting your statements, but you guys seem to agree with the fact that it is worth putting in the effort to clean up that data as soon as you can upfront, so that your first iterations or your first ideas of your rollout can be as accurate as possible, and then continue doing that within your process to get a clearer perspective on your costs and your rollout, potential delays, potential barriers to rollout. So is that something that I understood correctly?
Yeah,
Yeah,
I'll
yeah.
go forward. Oh, you go first. Peter.
Absolutely. No, absolutely. It is the same for us. Absolutely in line with that.
Yeah, and for us, I think it's a core. If you think really we're a data industry. Yes, I know we've got to dig holes and put fibre in and stuff, but in the end, the quality of the data is what will give us a quality of experience, customer experience, because understanding where the network is, how it's configured, how it's running, who's using it, etc., is where the value of the network is. So we want to have it a very data-rich environment and then modify that data-rich environment as we go through into build, rather than making some general assumptions and then coming up with a different set of data sets at the end. So to us, I think it's much more important that we start with a detailed high level and then move that through and modify it as we go.
Great. Well, so for the portion of introducing our stories in this workshop today, I think you guys have done a really good job. And now we will move to the panel discussion. And also I invite people to write in your questions on Slido as well. If you want to, no worries. We can take some questions towards the end of the workshop. It'll be our pleasure. But if you guys allow me, maybe I can kick it off with the first questions. And yeah, feel free to debate, exchange ideas. I think this is what the audience wants to hear. So I'll kick it off. I'll start with, well, since John, you already have your mic open and pretty close, maybe I'll just continue with you. But Pablo and Peter, don't worry, you're not forgotten, so feel free to jump in. But maybe a question, John, to you, and Peter, you could follow up. I'd like to hear from your perspective as well. So we heard in different workshops today about design resources, that they're harder and harder to find. And a clear option for you guys is to introduce, like you guys have done successfully, contractors, so design contractors like Yungo and others. And we see that this is a very popular use case. So based on that experience, what would you advise our audience to focus on when you're introducing these contractors from a design perspective? What would you advise them to focus on in working with outside and outsourced design resources?
Yeah, so I think, we work with 9 different design partners now, and it's interesting because pretty much every design partner has a slightly different model within their own business environment. So the first thing is don't mandate too much, because that's not how the design partner works. You need to make sure the design partner can operate the way that they operate to make sure they're given a quality process, but make sure that you have the framework, the start and stops and the waypoints really clear on how we want them to operate, so that we're getting a commonality of input and outputs in order to get that success. And then honestly, the main one is to spend a huge amount of time getting alignment on how to do it and what the expectations are, and then put a QC on the back of it, because with all good intent, when people start, it doesn't come out at 100% day one, and feed that back on a continuous loop. That's definitely been our game. We've been adding design partners as we've gone. Everyone's got a different model. They're all great. We've just got to find a way of making sure that they fit within our overall model, and that everybody understands how we're doing it, why we're doing it. Because you could end up with 2 different build contractors, or you could have 1 build contractor working off 2 different design partners' designs. So you've got to make sure that you've got a commonality of understanding, so that they don't either look different or that they've got different assumptions, or so the build partner never sees it as 2 different design partners.
Okay, I can perhaps jump in indeed. I comply for the large part to what is just being said, of course. What I can add is that from a cultural point of view, we have up to now really tried to include the design partners in our teams as if they are really present. So even because, of course, we also have some design activities with offshoring in the Far East, But even then, we always have one person at least from the offshore team who is really physically on site. That is the traditional way of organizing things. Now, let's say thanks to the lockdown situation that we had, of course, all these kind of physical barriers have been removed. And here, together with the Yungo people, it's the same. Pablo said in the beginning, we have around 6 people working continuously for Proximus. It's not just that we ask Yungo to deliver 150 designs. No, we have indeed these 6 people. They've been trained with our specific design rules and design algorithm, and they interact with our team, everybody working remotely or largely remotely, as if they are part of the team. And I think that's an important one. On the other hand, what I want to add as well is we have in fact 2 levels of design. We have the first one in which we really interact with the Yungo people, with our own team, with the Comsof software, is about making the design thorough enough based on good data, but in the end with the goal to have a very good and stable cost estimate. That we always keep and kept in-house. This is really our ownership. We are not just going to give this to any of our construction partners. However, the effective designing in our network inventory and the building and creating the plans for the construction teams, that we have put entirely with our partners. And so that is also a design activity, and there we interfere much less. It's very close to the construction teams. We put that on their responsibility, and voila, as long as they deliver the network within the quality and design guidelines for the price that we agreed upon, for us they have some liberty on organizing themselves.
Well, it's nice to hear from your perspective, but of course you have somebody that's on the other side of the fence. So I'd love to hear, Pablo, what is your take on working with your clients, operators that also probably have a different context than you?
Yeah, from our side is everyday challenge. Basically, what we try to do is we have our own incubator of engineers, so we always thinking ahead. We have our forecast for growing on with different business, with different partners, and because of that, we train people and we hire people much more in advance. The main challenge we have, even though is the different topologies, the different rules and different approach that the customer has. So that's why I talked before about the synergy and about the sharing between the different teams, what activities have been done and how is to design for this partner or for this other partner. And in terms of us to gather more business and to gain the trust, we have to give to our partners the feel of control and assure flexibility, but with quality. So that is of course again a challenge if you forecast too low. So the challenge here is that we are risk takers. We are hiring more people than we usually need, and fortunately, so far it ended up very well. So that's my answer for that. You're mute.
For sure, that was going to happen today.
Yeah, someday have to happen.
For sure, it has to happen. So, but yeah, follow up on that. Still to you, Pablo. I was interested also as being the one that receives these guidelines or these projects from your clients. I assume you're under a lot of pressure to produce volumes as well. You have a strict timeline to respect from your clients. So how do you balance the timeline and the pressure to deliver with the quality that you need to deliver? And how does design automation fit into this? Is this an enabler for one or the other, or it helps both?
It is actually in the case when there are not two supplies, we have our own coding team, so we produce our own automations to try to avoid as much as possible manual work and errors coming from doing manual work, so to improve the quality. I think in the case for John will be the splice sheets that somehow are quite complex and challenging, so automating that was a huge step for us to improve the quality. But of course, we also suffer the pain of the fast pace and the speed of moving faster and to produce faster. So that is a way to overcome. And as I mentioned as well in the introduction, we were born on doing automations and on working on tools as Comsof. So it's our daily bread basically. So that is what we do so far.
And maybe pushing that towards Peter or John, how do you guys also balance out? Because I've seen a lot of operators that their priority is time to market. We need to get customers connected as fast as possible so we can start generating revenue as fast as possible. So I understand that from an investor perspective, you guys are also pressured to start connecting clients as fast as possible. How do you guys balance out the level of quality that's happening in your plans and your designs versus trying to connect clients at all costs? Maybe Peter, you would want to take a stab at it?
Yeah, I can jump in here. So indeed, we have also seen based on the plans that Proximus has that we are going to go to 10% of the country on a yearly basis, which is a very high speed. Our quest for quality is in fact also underbuilt with a certain automated solution, I would say. So what is specific on our network architecture without going into all details, but it is that upon construction, we connect all fibers with splices underway to our active equipment. So we don't lay fiber cables and let them just terminate on a passive distribution frame ready for jumping. No, they are spliced up to our GPON equipment. And with the coexistence element, we have in our central offices a OTDR measurement tool connected at all times to all fibers, or connectable, because there is some possibility to move and measure on the different PON ports. But so we monitor our entire network continuously, irrespectively whether the customer is activated or the home is terminated. So we have all the intermediate steps where we have our splitters, our distribution points with temporary or permanent reflectors. So we can measure the entire network every night. And during the construction, we can measure before and after any activity that an individual splicer does. Okay, so that's just a solution, but now in the process, what we do is in our design inventory, we design very detailed level up front. We generate measurement points because in our design rules, we have identified where do we need a permanent or a temporary reflector, so that when an individual technician is splicing any fiber to any other fiber or to a splitter, he needs to validate, because if he doesn't validate with a remote measurement showing that on the exact output port of our active equipment, a certain reflector peak is added or removed because of his activity, he cannot continue. So we have, from quality point of view, really restricted the freedom of the variability that we allow to a technician up to the absolute minimum. And in the beginning, it was, of course, very difficult because all our splicers technicians were not used to that. We had escalations every day. The tool is giving incorrect results. The tool is not performant. The tool is not working. But after a few months of persistence, today everybody agrees that the tool is just marvelous and that the management of our construction partners even is very happy with it. And this quality during deployment is very important. And I repeat, we can repeat those quality measurements every night. And this also, again, it's data. It's generating an enormous amount of data. So now we are also building a bit of AI-like discoveries on what is happening with the measurements day after day.
Indeed, and I think that's interesting and a good segue. Before you answer that same question, John, I just noticed on slide with that same question that I just asked coming in, put in a different way, saying, John, how do you maintain quality in their design while duplicating their volume? So I think it touches the fact on how do you guys, how will you approach ramping up more design output, but maintaining or even improving quality?
Yeah. So I think on that piece, from a design point of view, there's a 2 or 3 key points. One is we mandate self QC, so we agree across all of the design partners the checks that need to happen for their own packs before they issue them to us, so that they have to confirm that they've passed that checking before it comes to us. We then do a further set of QC ourselves to validate. As I say, this is only from the learnings of getting that right first time up. Now we've got the design partners all now operating in the upper 90s. And then the final check is when we get feedback, because we are aligned with the design partners and with our own city build teams as well as the build contractor, feedback from the local cities around how does the design, or what was the error or the assumed problem with the design. And we feed those back into via an open channel that we have to all of our design partners, so that they all learn from the same feedback coming back in from the cities. So again, we're doing waypoints, and we're doing a continuous feedback loop to make sure we maintain that quality.
Interesting. And maybe also another question that comes in, I think you guys alluded to it during your presentation, your sections, is you mentioned that, interesting from both your parts, that there's nothing that to this day you feel that beats sending people in the field to gather some data. So the question is, John, and also Peter, you could answer that as well and give your take on it, is how are you using, or if you're using any technologies for field surveys? So whether it's tablets or smartphones, from that to LiDAR technology, and if yes, what kind, and if not, is there a reason really behind that?
So we use a company to do surface type capture in high resolution video. So we've got that from so we understand on a per meter basis what we're tasking ourselves with. And then you're right, we use a myriad of tablets, but conversely, we're looking at using our design partners from a design point of view. We're using our design partners to utilize their own systems, because as I said earlier, everybody operates in a slightly different way. But so long as the output of that meets into our input, our API, or into our own systems and data flow, we're fine with that. As long as we couple that with QC, that's the way to do it. On the LiDAR one, I would love to say we use LiDAR, because it sounds fantastic, doesn't it? But we haven't yet found the one thing that says you can do LiDAR, fantastic, and you'll get lots of information on it, but you still need someone to walk the street. At that point, the person that walks the street can do the same thing that LiDAR can do, which is why we haven't yet moved to LiDAR. So I'm all ears though. If someone's managed to crack the code to have LiDAR do it at 40 kilometers an hour, perfect.
Well, I hear a business opportunity there for our audience to look into.
Exactly.
What about you, Pablo? What's your experience from a survey perspective?
Yeah, in case of LiDAR, we actually utilize it, and the time we went to the field, but it's a completely different type of building network. So I'm talking about Germany. I'm talking about not accessing to certain information, getting a specific permit even to drive in different towns. So we have very short amount of time, and we needed to get this data, and we needed to have time to revise the data. So for us, you use LiDAR in those cases was an advantage. And work through that data, said, okay, can we also merge our designs and see what was designed and see the network there was of added value. But of course, it's on cases for more greenfield, I would say, and less use of existing infrastructure and poles and so on. So I totally understand John on this one. But in those cases, it's very useful.
But even understanding how many what do you call them, Peter? Living units are in a block.
Yeah,
you can't get that from LiDAR.
depends. In our case, we did 90% of it, but it's rural area. It's total rural areas, and it's Germany. So we're going to use all the information of what is in the surfaces to see where we're going to place our trenches. So that for us was the added value. The counting of the connected house, that I agree with you, is also a pain. We had to go, and that's when I mentioned to you 80% was done, but then the other 20 was to find especially in the multi-drilling units or the high rise, to try to identify how many living families were there. So that was exactly where we had to go. But the reduction of the time on our visit and the idea of being able to revise this data as many times as possible, that was an added value for us in that case.
And Peter, maybe regarding that, an interesting part for Proximus, when you talk about an incumbent that already owns infrastructure, especially here in Belgium, since I've been living here, I notice a lot of facade networks as well, and also underground infrastructure. So, you know, chambers, ducts, manholes, handholds. This, of course, how do you guys deal with that to ensure that whatever information that comes in, for example, in the underground infrastructure, your records say you have a bank of 12 ducts, but in fact you're not sure. And are those ducts still usable? And facade networks, how do you guys approach this?
Yeah, so indeed, we have the inventory, of course, of available ducts and subducts, and we really it's no nonsense. We go on site, we open the manholes, and we validate that the duct in the right color and the subduct of the right color in the right duct is really available, not occupied, which is a manual action. We don't do that for everything, of course, but for the important tracks where we for sure don't want to stand still of the teams, we do that. And of course, all our technicians have tablet-based applications to validate or adapt data. When we go into the streets to validate the addresses, count the amount of living units, it's also tablet-based solutions where we also have the GPS tagging, which is okay enough to validate that an address is on a certain side of a road. But so again, I have exactly the same approach as John. That is that we have decided not to start with LiDAR if we anyway need to go and visit every street, and then this person immediately can do it all. I'm happy to hear from Pablo that anyway it has been proven in your case that in the end it is worthwhile because the on-site activity can go in such a way faster that is beneficial. So I think towards the future we will continue investigating that, but up to now we have not done that. What we do perhaps with also support of a more complex or more complete GPS measurement solution is our as-built measurement. So during the construction, for the exact location up to X centimeters, we have this GPS-based measurement with multiple antennas and fixed references. So that we stopped measuring with our feet how many feet away from the corner of a house a certain infrastructure is. And that's it's a quite recent evolution, but it's not survey, of course.
And can I ask, have you seen or is maybe already implemented? I was mentioning in one of my slides the smart as-built, which means not only the gathering of this information, but identify the objects that you're measuring and combine it with the data that you already have digital, which is the final low-level design, to automate part of the match and move for the process of the as-built. Something that is being thought or
I'll have to check that. I don't
okay.
know.
And can I ask John about what is your as-built process? How is
it's
owned by the partner?
By the construction partner, yes. Comes back but validated via our own field teams, and then imported into GIS and done a validation against the design in the first place. So
Okay.
it's still evolving. If I'm honest, we're not. I wouldn't say we're particularly efficient at it today. But we do back it up with end-to-end fibre testing. By the way, on the fibre testing, we're moving to a cloud-based fibre testing solution, which I think will be really beneficial with the GPS location on it to validate where the test was taken from and where it turns up, etc. So, yeah, we're driving a similar line around as built, because in the end, that's the most important document through all of this, isn't it?
Mm-hmm.
Yeah.
Maybe as we are closing this off, maybe a last, last quick question with a quick answer for the three of you. Of course, I'm kind of interested to find out this answer because it has to do with planning and design automation. But if your users would be here, how do you think they would describe the value of the software, the usage of the software on a daily basis? Because I assume you guys in your daily work are not necessarily involved in the nuts and bolts of the software, but how would your users maybe describe the use of the software? So maybe we can go from John, Peter, and Pablo to close it off.
I think all of our guys see the huge value in it. It can be painful, but it's painful because the data clashes, as we know. You know, you can any system that says it can do it first off, as we all know, isn't the case because data doesn't work that way. So it can be a bit manhandling at times, but the results and the process and the improvement we get from automation is massive. So no, I would suggest all of my users, all of my people would be fully aligned.
Yeah, I have nothing to add. In fact, yeah, it's really the data capturing and bringing it together, validating it, correcting it, doing iterations. Sometimes painful, but in the end, running the algorithms and seeing the output in a QGIS layer, it's everybody is fully aligned that it's fantastic.
Yeah. In our case, we feel the full impact. Basically, without the automation, the work will be much more harder for us, and it is what generate our margin. Actually, as much we can automate, as much we can improve our performance, our quality, and give better service to our customers. So, yeah, that's a key point for us.
Perfect. Yeah, fully agree.
Well, thanks, guys. Really, there's a lot of rich information in what you guys have shared today. I see that for me, the massive takeaway is there's a lot of differences in the context of an incumbent operator, an alternative operator. There are some differences because of geographical location, maybe regulations, infrastructure, processes, all these things. But there are some things that are very common, and the most common for me that I take away from this is the data input, and it's interesting because this is what I find regardless where we are in the world. So to close it off, I really want to thank you all for joining. I want to thank all the attendees for staying with us and participating, and finally thank the FTTH Council Europe for allowing us to have this workshop. So hopefully we'll see you in a live event very soon. Thank you all and have a nice rest of your day.